Hello and welcome to the MSSQLTips webcast, Protecting SQL Server in the Cloud, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder at MSSQLTips and today's webcast host. Joining me today is Edwin Sarmiento, who is a Microsoft SQL Server MVP and Microsoft Certified Master. Also joining us is Dave Bermingham, who is a Microsoft Cloud and Data Center Management MVP. Today they will discuss how to best protect SQL Server when running in the cloud. Before we get started, if you have questions, you can submit them at any time during the webcast by answering your questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you're not already a member of the MSSQLTips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Edwin, and he can get started.
There we are. I finally figured out how to unmute my microphone. Good day. I don't know exactly where you guys are, but I'd like to say good afternoon because I'm on the East Coast in North America. Welcome to this webinar on protecting SQL Server in the cloud. Thanks, Jeremy, for introducing me. My name is Edwin. I specialize in SQL Server high availability and disaster recovery. So we're looking at failover clustering, availability groups. In fact, I just finished a 3-day training class with Brent Ozar on SQL Server always on availability groups. If you have any questions regarding the presentation, feel free to type them on the chat window of the GoToWebinar control panel. Ask them on during the webinar. You can also share insights or information that you've learned from this webinar through social media. I'm on LinkedIn, I'm on Twitter, but let's get started. We've got some polls up for you that would help us structure the whole flow of this presentation, and I would appreciate, Greg, if you could pull up that poll. Where are you in your journey towards the cloud? So like one of the following. Are you currently exploring the cloud? Do you have some workloads like dev test? You're currently testing out the cloud. Are you using the cloud for DR? Kind of like the cloud is your DR data center at the moment. You have majority of your workloads in the cloud. Maybe some of the mission critical applications are currently working on running rather on the cloud. Or I don't really know. I don't care. Okay, choose a response from the poll, and we'll look at them later.
Yep. So we just give everybody about 10 seconds more, and we'll let you vote, and then I'll share the results with everyone.
So that's the first poll.
All right, so here we go. I'm going to close this one and share the results, Edwin.
Sure.
All right, so with that, we have 57% said currently exploring, 26% have dev test in the cloud, 11% majority of our workloads are in the cloud, 4% use the cloud of DR for DR, and 2% meh. So let's go to the second poll. Let me close that down.
I like the meh responses. So for those people who have opted for we're exploring it, or we are currently running dev test or DR, what are you using? Are you using Azure SQL Database? Are you using Amazon RDS for SQL Server? Are you using SQL Server on a VM, whether it's on Azure or EC2 or Google Cloud or Rackspace, name it. Take some time to respond. You could choose one or many. So let's say you're using Azure SQL Database or Amazon RDS at the same time, or Azure, rather SQL Server on a VM, whether it's on Azure or EC2. As appropriate, you can choose as many as you can.
All right, once again, we'll give everybody about 10 more seconds here to respond, and I'll read off the responses. All right, everybody get your votes in here.
And like I said, these polls are used to understand where you're coming from, where you are right now, and helps us structure the flow of the presentation.
All right, I'm going to share these now, and I'll read the results. So we have 58% said SQL Server on a VM in Azure, 53% said Azure SQL Database, 19% said other, 15% said Amazon RDS, and 13% said SQL Server on Amazon EC2.
And it's a very interesting observation because you see that the Azure SQL database plus SQL Server on a VM running on Azure is close, but I'm kind of expected the results mainly because a lot of the customers are still moving towards the cloud, particularly Azure, since Azure is a topic for today's presentation. And they're slowly moving towards how can I move my existing workload from on-premises to the cloud. And so I kind of like to tell the story of the time when I started driving. I think I was 16 years old when I first got my driver's license. And I'm pretty sure if you drive, I'm pretty sure you could relate to the story of the first time you learned how to drive. You put yourself in the car, be behind the wheel, and start learning how to drive. Of course, in North America, it's all about automatic. I first learned how to drive a stick or a manual transmission car. So that's a little bit more exciting and fascinating. And then I got my driver's license. But here's the thing, though. The first time you're out on the road, you're thinking, hey, I already got my driver's license. I want to drive somewhere, maybe show people that I can drive. Hey, I have a new car. Maybe it's not my car. It's my dad's car. But the thing is, here's the thing that I noticed personally when I started learning how to drive is maybe it's a side effect of watching too many Fast and Furious movies rather, that I wanted to drive something like this. You know, you want your first car to be that nice, fancy sports car. You want that, shiny where you can attract people. You can show, hey, I'm the boss, right? We think we need this. And you could be honest about this. You want your very first car to be something like this. Maybe not a Formula One car, but something flashy and, fast. But in reality, though, all we really need is this, like a Toyota Yaris. There's nothing wrong with a Yaris. But the way I think about this is, sometimes we think we need X, but in reality, all we need is Y. And in fact, a couple of months ago, I'm proud to say that I accidentally broke my leg because of me trying to rollerblade. And this is when I started realizing, hey, I can actually have options other than buying my own car. So I drive a mini SUV, but during the 2 months that I couldn't drive, I was on the bed for like 3 or 4 weeks. I couldn't even walk. And within the next couple of weeks, I struggled to even walk around the house, but I need to go out. I need to grab some groceries, but I have options. I don't need to drive. And realizing that we live in a day of an age where we have options like Uber or Lyft or any of these car services without having to buy a car. In fact, my prediction is that within the next 5 or 10 years, car purchases and acquisitions and buying of cars will decline because of these services. Now, why am I highlighting this? Because when you look at the poll questions that we did earlier, one of the questions that we asked was, where are you at in your journey towards the cloud? I've written a blog post that I've entitled Getting into the Dating Phase with the Cloud, where I highlighted the different stages that you are in currently as you're exploring cloud offerings. Now, I'm not going to dive deep into the analogies that I used, but basically it's just all about human relationships. But when you think about it, whether you're moving to Azure, which is the main topic that we have for today, or AWS, or Google Cloud Platform, you're going to be looking at two options. I know Google only has the virtual machine version running SQL Server at the moment. So we're looking at Amazon or Azure. But based on your responses, most people in the webinar are on Azure. So we're looking at platform as a service and infrastructure as a service. And we're going to look at differentiating between the two, because our goal is to make sure that we make the right decisions on choosing which one to work with. And I kind of like to start off with the concept of administration. And when you compare platform as a service versus infrastructure as a service, I kind of use the DBO versus sysadmin analogy. With platform as a service, everything is kind of like bound within the concept of logical control. Like I said, kind of like the DB owner, where if I am a DB owner of a specific database, I can do everything that I want within the context of that database. Anything outside, I'm restricted. Okay? When it comes to sysadmin or permissions as a sysadmin, I have control over what's happening in the instance level, meaning I am the DB owner of one database and all of the other databases within that particular instance. Now, when you think about it from the point of view of platform as a service, or in this case, Azure SQL database, I don't have access to master database. Well, my logins exist within the context of my database. I don't have access to SQL Server agent jobs, although there are alternatives. I don't have visibility over where my database files, my MDF, my LDF files are going. I don't know where my backups are stored. So there's some limitations on the platform as a service with regards to logical control. In contrast with infrastructure as a service, you could decide whether you want to put your MDF files on, a dedicated drive, put your LDF files on another drive, maybe place your mission critical databases on an SSD versus standard drives for your backups. Infrastructure as a service, like the SQL Server running on an Azure VM, is no different from you running your SQL Server instances on a VM on premises, whether it's Hyper-V, VMware, Citrix, or any type of virtualization platform. The only difference is that on premises, you or anybody from within your company has control over everything. Like if you want to, let's say, get an HP, DL380G9 for your physical machine, you can tell your hardware folks, go get one of those. If you want, let's say, pure SSDs for your hard drives, you can tell your storage engineers those. Here, you don't have control of the hardware layer. That's abstracted. All you have full control over is the SQL Server instance and the underlying operating system. Of course, you have full control over whether you want to choose more CPUs, more memory, a higher tier on the VM layer. But again, that's the limitation that you have when you compare and contrast Azure SQL Database versus SQL Server on an Azure VM. Now, it really doesn't matter whether you're on Google Cloud Platform or AWS or Azure. The concept is the same. You're managing a VM sitting on the cloud, and you have full control over the operating system, SQL Server instances, and the databases. Now, I did grab a link off of the Microsoft documentation here that talks about the Azure SQL database versus SQL Server feature comparison. Now, the document is geared towards developers. Now, I know most of you are either administrators managing databases or accidental DBAs, but I would strongly recommend that you look at this documentation, mainly because if you decide to move to the cloud, the first question you'd probably ask is, well, so what will work, right? There are features that exist in the box product or the SQL Server instance full-blown that don't exist on Azure SQL database and vice versa. In fact, the strategy that Microsoft has right now is cloud first. Back then it was cloud first, mobile first, and apply whatever learnings that they've accumulated on Azure SQL database as a feature on the boxed version or the full-blown instance version. In fact, I tell customers about Query Store, which was introduced in SQL Server 2016, was a feature that first existed in an Azure SQL database before Microsoft decided to put it in the box product. So I strongly recommend that you have a look at this feature comparison to have an understanding of what is it that Azure SQL database has that I can leverage should I decide to move to the cloud. Now, the second thing that I think about when it comes to choosing between platform as a service or infrastructure as a service is cost. Now, most people would think this is simply just the upfront cost, like licensing or choosing the right tier. When you're looking at Azure SQL database, of course, it's not just about the size of your database, because there are limitations in terms of the size of the database that you could put on different tiers, whether it's on standard tier or a premium tier. But when you look at infrastructure as a service, I can put as, my largest database in there, provided that I'm willing to pay the storage costs associated with it. And then there's not just the cost of spinning up a new database on Azure SQL DB or spinning up a new VM on an Azure VM with SQL Server. Part of that is the traffic, what cloud vendors would call egress and ingress and egress. Ingress is where you're bringing in data into the cloud, and egress is when you're taking data out of the cloud. A typical scenario there is when you are slowly moving into the cloud and you want to maybe restore your backups from on-premises to the cloud. Now, transferring and copying that backup from on-premise to the cloud is free. That's ingress. You're taking data into the cloud. But what you're really paying for in the long run in terms of data coming in and out is when you start taking data out of the cloud. So take, for instance, I'll use the same analogy for that backup. I copied the backup from on-premises to Azure, and now I want to take the backup back because I want to restore the backup and, do some analysis on some objects like a table that I want to have a look at. Just the fact that I'm copying data out of Azure, I will have to pay for that. So on top of me paying for the upfront cost of licensing, compute, and storage for Azure VMs, I'm also going to be paying for outgoing internet traffic. Now, Azure SQL Database has the benefit of just paying for the tier of choice per month plus the outgoing internet traffic. But more than the upfront cost is the administration cost. Your developers, you, the administrator, should be familiar with features that are getting introduced as the cloud evolves, PowerShell scripts or commandlets that you need to know in order to access those resources on Azure, not to mention learning and educating your team. Because in order for you to be very effective in leveraging resources on the cloud, you need to be familiar with commands, syntaxes, features, limitations that you could and could not use when you move to the cloud. The last one is service level agreement. And we're looking at a service level agreement from the point of view of you, the customer, because you're going to be the one reading the fine print in terms of what Microsoft says. When you're looking at Azure SQL Database or Platform as a Service, Microsoft is promising 99.95% SLA on the database level. And what that means is if you decide to host your database as an Azure SQL database, Microsoft guarantees 99.99% SLA on a database level. Now, in contrast, and I put an asterisk there, when you're running SQL Server on an Azure VM, Microsoft guarantees 99.95% SLA on the virtual machine level, which means anything inside the VM is your responsibility. And highlighting that in more detail, if you spin up a VM, you don't need to provide any high availability feature on the VM level because Microsoft guarantees 99.95%. But, well, even if the VM is online and available, if the SQL Server database is offline, technically your databases are offline. So it is your responsibility as the administrator to choose between Azure SQL Database or Azure VMs running SQL Server to provide those SLAs. Because the next question you're going to ask is, so what did we promise our customers in terms of SLAs? Now, when you think about these differences between Platform as a Service and Infrastructure as a Service, the ultimate question is, so which one? We're moving to the cloud. We're currently exploring the cloud. Like most of you have mentioned, we're exploring, we're looking at dev tests right now, we're evaluating it. Which one do I choose? Do I choose Platform as a Service or do I choose Infrastructure as a Service? For new deployments, and I know a lot of developers would disagree with me on this, for new developments, try out the cloud. The reason for that is there are not a lot of risks with new developments because it's new. No business I can't remember the word. There are no business that would be affected when you're working on a new development or a new feature or a new product. That also means that you can make any change, you can introduce a new feature in your application without the risk of affecting existing businesses. If you're also looking at a SaaS-based design, like a lot of new products out there are starting to leverage SaaS-based design or software as a service design. Like for instance, accounting software has become has evolved from a box product or a client server product to now cloud-based. Now, if you are looking at moving existing workloads on premises to the cloud and you require tight control, like I have specific configuration for this database that I can't do with Azure SQL Database. Like for instance, when the .NET framework or CLR assemblies were limited because of some security issues a couple of months ago came out. If my applications require SQL CLR, then I can't just leverage the Azure SQL database. I need to move to an Azure VM running a SQL Server instance. You could also move towards Azure VMs if you have an existing feature that you want to carry over or move over. And again, one of the reasons I highlighted looking at that documentation so you could see what features exist for Azure SQL Database and what features exist for SQL Server VMs on Azure. The thing is, if you really want all of the features on the box product, the only way to go is to move to an Azure VM, and then you decide which features to turn on or which features to turn off. Okay. The thing here is test. You test how your new deployments would work, and the way testing has evolved throughout the years is really interesting when you look at the cloud. In the past, and I'm referring to performance baselining and benchmarking. In the past, and here's how it worked in the past. If I want to deploy a new database, and let's say I want to procure a hardware with that specific database, I'm locked in with, hey, I'm guessing. It's a new application. I don't have the data for baselines and benchmarks. I'll guess. So I'll call up my vendor, maybe HP or Lenovo, and then tell them I need server X with these specifications. More often than not, we will over provision the hardware, maybe more CPU cores and more memory, because we don't know what's going to run on top of it. Now, if you over provision, you have an idle asset that's sitting there doing nothing, which is why most CIOs and CTOs would say, let's put more on top of this machine so that we can maximize this investment. Nowadays, in the days of virtualization and the cloud, this is what you could simply do. Run the test, maybe provision the minimum tier for Azure SQL DB or minimum tier for the Azure VM. Not enough? Scale it up. Okay. In less than 5 minutes, of course, assuming that you've automated the entire process, you can go from a lower tier to a much higher tier. And then you can test how that works. Okay. I kind of use the analogy of overspeeding, because sometimes people would say my applications are slow, but if you don't have baselines, how do you know it's slow? It's just like saying, look, the only way I know I'm overspeeding when I'm driving is when I know what the maximum speed limit is. At one point I thought 75 miles per hour was the maximum. I thought that was kilometers per hour. And so I kind of get confused. But the point is, if you're testing which one you choose, you're looking at performance, availability, and reliability. It's easier nowadays to perform testing. The thing is, you need to have standardized tests with the same parameters, same everything when you want to test between moving to Azure SQL database or SQL Server on Azure VMs. Now, the focus of this presentation is mainly on infrastructure as a service. And when you look at, let's say you want to upgrade, let's say you bought your first car, maybe your first car was the Yaris, and you want to upgrade. How do you want to upgrade? Would you want to move from, a compact car to a mini SUV because it's fun, it's classy, it's sporty, it reflects your personality? Or do you want to move to a minivan because you decide to get married and have kids? The question that you have to ask yourself when you're doing the upgrade is, what do I currently have that I can take with me? And these questions will drive the decision towards, so I have an on-premise application, an on-premise database. Should I move to Azure SQL database, or should I move to Azure VM running SQL Server? Do you have those existing features that you want to take with you if you're moving from on-premises to the cloud? But as a SQL Server expert or somebody who focuses on high availability, my biggest concern, if I move databases from on-premises to the cloud, is availability of the SQL Server workloads. Because when you really do think about it, it is the availability of the entire stack, not just the databases, but the entire stack, including the application and the middle tier that I need to be concerned about. And so when you look at another documentation that I'm referring to in this screenshot, there are different business continuity features that Azure SQL database can offer, like database backups, geo-replication, recovery. Everything is being done for you. So you don't need to have a dedicated DBA spinning up availability groups, failover clustering. It's there. You're paying for it. Microsoft, in all of their infrastructure and automation, is already doing that for you. If you choose, for instance, to work with Azure VMs, you have these lists or these items for high availability and disaster recovery. Now, let's look at them one by one. I'm not going to be considering simple backup and restore, including log shipping, because for higher availability, like you have to minimize downtime, your goal is to provide higher availability. So from this list, I'm only looking at database mirroring, availability groups, and failover clustered instance. So let's start with database mirroring. Now, the reason I'm still highlighting database mirroring, even though SQL Server 2017 is already out, is because customers who are moving away from 2005 to the latest version still can't decide. Do I want to move to availability groups? Do I want to move to failover clustered instance? Database mirroring, if you look at the note here, has already been deprecated. Although I keep telling my customers, deprecated does not mean unsupported. And so you can still use it. Although Microsoft recommends that you leverage availability groups. Now, up until SQL Server 2014, customers do not have any option. What I mean by that is customers running on SQL Server 2008 Standard Edition cannot just move from database mirroring to availability groups, because availability groups only existed in Enterprise Edition. And so when you look at this, say, I want to deploy my existing database, move them up from database mirroring to always on availability groups, as of SQL Server 2014, it's not really a good business decision when you think about it. Enterprise Edition was the only edition that carried availability groups. The good thing about SQL Server 2016 is now it provided customers the option to deploy availability groups using Standard Edition. But of course, you're only limited to 2 nodes. This is good enough because now we have a direct migration path. I don't want to say direct, but an equivalent migration path from database mirroring in Standard Edition to SQL Server 2016 Standard Edition. Now, what about failover clustered instances? I did mention it. I don't really consider log shipping as an HA strategy. Neither do I consider backup and restore, even though it's fast on the cloud, but you still have to think about what is your SLA in terms of the databases. How long can you tolerate downtime regarding your database? So what about failover clustered instances? When you look at the list of HADR deployment architectures from that diagram, from that document rather, you would see that failover clustered instances is in that list. So let's look at the Windows Server failover cluster platform, because both availability groups and failover clustered instances run on top of a Windows Server failover cluster. Now, I've taken a screenshot of this KB article, KB 2721672. This KB article highlights the requirements for Windows Server failover cluster. And I did mention that SQL Server failover clustered instances, as well as availability groups, run on top of a Windows Server failover cluster. And in the past, this is not even included in the list of HADR architecture that you could provide for your SQL Server databases. It was only availability groups and database mirroring. Now, Microsoft has included failover clustered instances. But when you think about how SQL Server failover clustered instances are deployed on premises and you want to move them to the cloud, failover clustered instances leverage the concept of shared storage. Of course, there really isn't a concept of shared storage on any cloud provider. This is why I mentioned this requires some magic, the magic sand dust, where you're talking to your SAN administrators on how to implement shared storage. Now, you could actually make that happen on Azure by emulating what I call local storage that looks like shared storage from the point of view of the failover cluster. Hence, SQL Server failover clustered instances are supported to run on top of a failover cluster in the cloud, regardless of what that cloud provider is, whether it's AWS, Azure, or even Google Cloud Platform. Now, let's look at the failover cluster platform, because both failover clustered instances and availability groups run on top of the Windows Server failover cluster. You need to be aware of the fact that failover clustering depends so much on both Active Directory and DNS, whether you like it or not. Even if you decide to deploy a Windows Server 2016 cluster, where you could have a failover cluster without Active Directory, in reality, most of the deployments out there would still leverage Active Directory. So when you're creating a cluster in Azure, in AWS, or on the Google Cloud Platform, you still need Active Directory. Okay? This is something that you have to provision on the cloud. You might be wondering, wait a second, I'm trying to provide and protect my databases and I need AD. This is the part where I say your job as the database administrator is now dependent on the things that you're not even aware or dependent on. This is a classic example, Active Directory and DNS, because when you create a cluster, it creates a corresponding cluster name object in Active Directory. So that's for the Windows part. When you install SQL Server and create a failover clustered instance, it creates a virtual computer object in Active Directory. Question is, who's managing Active Directory for your environment? Of course, I usually just call it the virtual server name. But the thing is, your deployment of failover clustered instances or even availability groups depend on Active Directory. But it's not just Active Directory. You're also depending on the permissions that you would need in order to create those Active Directory objects. In fact, what's a very interesting fact is that I have some friends from the customer support team at Microsoft, and the top two issues that they have to deal with when a customer calls in regarding an issue about failover clustered instances or availability groups have nothing to do with SQL Server. It's Active Directory and DNS. And part of that is actually the permission. So you would need to have the create computer objects permission in Active Directory in order to create the cluster. And we're not just talking about the Windows cluster, we're also talking about the failover clustered instance. By the way, failover clustered instances still require Active Directory, unlike availability groups. So you're also considering security. If you work in a company that has very restrictive security policy, you would need to ask your Active Directory administrators to pre-stage the computer account. This is where they would create a computer object and disable it. And then they'll give you the name of the computer object that you will then use to build your failover cluster and your SQL Server instance or failover clustered instance. Now that's the Active Directory part. We're looking at the DNS part as well. When you're creating a cluster in your network and it is joined to an Active Directory domain, it is Active Directory that tells DNS, hey, this guy can write or can register records in the DNS. And you have to enable this checkbox, the register disconnections address in the network. that allows this machine, the one that you're building as a cluster, to register the DNS record for the virtual server name in the DNS. Now, I've talked about some of the things that you have to be familiar with when you want to protect your SQL Server on premises, and they apply to the cloud. You need to have Active Directory and DNS on the cloud if you want to deploy a SQL Server failover clustered instance. Now, just because they're the same concepts doesn't mean that they are. There's still some differences because a lot of these things are abstracted to you. Only the VM is presented to you, but the underlying physical hardware, like the networking, storage, the physical machines, they're all abstracted to you. And I kind of use the analogy of when I decided to rent a car in London a couple of years ago, and I was it was just an awkward experience driving on the other side of the road. Driving a vehicle on the left side is not the same as left side of the car is not the same as driving a car on the right side of the car, but on the left side of the road, which means when you're moving your workloads and you decide to protect your work databases on Azure using failover clustered instances, you would have to think about these challenges. My biggest challenge when I started working with Azure VMs running SQL Server, failover clustered instances, or availability groups on the cloud revolved around networking. And this, despite the fact that I used to be a part-time network administrator. See, even people like me struggled a lot with the networking aspects because there's no network cable to unplug. There's no network switch to move around to test why something could not connect to the database or the application. In fact, one of my biggest challenges was dealing with the internal load balancer on Azure. I mean, that did not exist in my networking vocabulary back then. But now, because I'm deploying a failover clustered instance or even availability groups on the cloud, I have to understand how internal load balancing works on top of the basic ping and telnet and routing tables that I have to worry about. And that's just a networking piece. We're also looking at cost. Well, didn't I mention, if you decide to provide high availability for your SQL Server databases using failover clustered instances and availability groups, you also need to provision a domain controller on the cloud, a DNS server on the cloud. Of course, you can put them on the same machine, but that's an additional cost. Plus the deployment cost of managing those resources. I remember some of my PowerShell scripts not working after Microsoft released a new version coming from the Azure Classic deployment model to the new resource management model. So these are things that I have to think about in terms of cost because I need to be familiar with how these changes impact the way I would manage my high availability infrastructure. But the biggest challenge I had when I was starting out with dealing with failover clustered instances on the cloud is actually shared storage. In fact, the list of HADR architectures for running SQL Server on Azure VMs did not include failover clustered instances in the SQL Server 2014 version. They only had availability groups, database mirroring, log shipping, and backups. That's all they had. So technically you only had two. The only time that Microsoft added failover clustered instances was in the days of SQL Server 2016 with Windows Server 2016, where you can now leverage storage spaces direct with a SQL Server failover clustered instance. Now, I did mention earlier that there really is no concept of shared storage in the cloud because everything's abstracted. You're not going to send a very expensive SAN to the folks at Microsoft and tell their data center engineers, please plug this SAN in your data center because I'm going to use it. So the way that you leverage shared storage is by using emulated shared storage. In fact, when you look at this documentation on the Microsoft or the SQL Server books online, one of the things that is now included in the support for failover clustered instances is the use of a third-party solution like SIOS to emulate shared storage using local storage, kind of like how Windows Server 2016 leverages local storage with storage spaces direct. But the thing is, these have existed even before Windows Server 2016 was even released. And so understanding what your options are, knowing the choice between, am I going with Azure SQL Database or Azure VM, what different high availability options you have when you decide to move to a SQL Server on an Azure VM. And eventually, if you decide to move to, let's say, I want to move my failover clustered instances from on-premises to the cloud, how do I protect my databases using failover clustered instances, deploying not just the VMs that will act as nodes in my failover cluster, but also the corresponding dependencies like Active Directory and DNS alongside with the underlying shared storage. And this is where I now hand it off to Dave on how you could look at leveraging third-party solutions like SIOS for providing emulated shared storage so you can protect your SQL Server databases on the cloud, leveraging failover clustered instances. Take it away, Dave.
Thanks, Edwin. So let me share my screen here, and we'll talk about how you can build what SIOS would call a SAN-less cluster. SAN-less cluster has been a concept that SIOS has been, selling since 2008 was released. So Microsoft clustering way back in the early days kind of had a bad reputation. It was kind of clunky and required that your hardware be on a hardware compatibility list. And a lot of people saw it as even less reliable than just deploying a standalone server, because you have to be an expert in failover clustering, and everything had to work perfectly for it to work. But as of Windows Server 2008, Microsoft really fixed all the issues that people encountered using failover clustering, except the one in that it required shared storage. Shared storage could be seen as a single point of failure. It could also, limit your deployments to a single site. So if you wanted to do stretch clustering across multiple sites, you had to use array-based replication. Started to get very expensive very quickly. What SIOS did is we released DataKeeper, which is a host-based software replication solution that integrates with failover clustering, that lets you build failover cluster instances just using locally attached storage. So in the past, it was great for people doing multi-site clusters, or people who wanted to leverage very high-speed locally attached storage but still build failover cluster instances. And so we solved a lot of problems. Now, recently, the vast majority of our customers are people that are moving to the cloud because there is no shared storage available in the cloud, whether it's Azure, AWS, or Google, really any cloud platform. They don't give you the shared storage that you can use in a failover cluster instance. So instead, you can leverage SIOS DataKeeper and still have failover clustering in the cloud. So I'm going to show you what that looks like and walk through the configuration of that, and then we'll save the last 5 minutes or so for questions. So what you see in front of you is Microsoft Failover Clustering. This is the Failover Cluster Manager. I'm connected to 2 servers, SIOS 1 and SIOS 2, and you can see my cluster contains those 2 nodes as well, SIOS 1, SIOS 2. I do have a SQL Server Failover Cluster already pre-configured. If you've seen failover clustering before, this should look very familiar to you. Cluster usually consists of multiple resources, including a name, an IP resource. You have your SQL Server resource, SQL Server agent. Now, where it becomes different is under storage. Traditionally, under storage, you would see a physical disk resource, which represents your cluster, and that resource controls the I/O fencing, so the SCSI reservations, to ensure that only the active node has access to that shared storage. Instead of a physical disk resource, SIOS presents the DataKeeper volume resource, which, as far as the cluster is concerned, this looks like a shared disk. So the cluster is going to treat it like a shared disk, but under the covers, what it's doing is controlling the mirror direction. So in this case, the cluster is active on SIOS 1, meaning all the writes are occurring on the storage attached to SIOS 1 and are at the same time being replicated to the other nodes in this cluster, in this case, SIOS 2, either synchronously for nodes in the same region, or asynchronously if you want to replicate across regions for disaster recovery, or a combination. If you have multiple targets, you can have some that are synchronous, some that are asynchronous. But other than that, it behaves just like a regular failover cluster instance. So if I wanted to move this resource to SIOS 2, I would use Failover Cluster Manager and tell it to move to SIOS 2. You'll see resources come offline and online. As part of this online process, we see the DataKeeper volume is online already on SIOS 2. What that did is effectively reverse the direction of the mirror. So now with the cluster online on SIOS 2, all the writes are occurring on the storage attached to SIOS 2. And in Azure, that could be, regular disk, it could be premium storage, could even be a storage space consisting of a multiple disks striped together in, a performance stripe, so you can, increase your throughput. It doesn't really matter to DataKeeper. We can replicate any storage. All it needs is a drive letter, NTFS format, and that's it. You're good to go. So it's very, it kind of eliminates a lot of the complexity around, failover clustering and requiring, any sort of iSCSI devices or, total storage space direct, which is multiple layers from CSV to the storage space itself. So there's lots of layers. This is very simple. You're not changing your storage, it's the local touch NTFS file. So I'm going to show you now how we kind of got to this point. It's very simple. The DataKeeper software is going to be installed on each of your cluster nodes. So SIOS 1 and SIOS 2 are running DataKeeper. This is the interface, simple MMC snap-in. And you can see the job that we are currently using is represented here. You see it's now running as SIOS 2 as the source to replicating to SIOS 1, and it's currently in a mirroring state. So green check marks means everything is good, operational, just as we expect it to see. If I look at the server overview, I got another picture of what's going on in these two servers. The S drive is the target on SIOS 1, it's the source on SIOS 2. I have all these additional volumes attached that aren't being mirrored. So what I'm going to do is take the R drive and replicate it from SIOS 1 to SIOS 2 and register it in the cluster so we can start using it as a cluster resource. So we're going to create a new job, give it a name, and then there's a three-step wizard where first you choose the source. So we'll choose SIOS 1 as the source. Choose the volume. We said we're going to do the R drive. You can specify which network you want to use for replication. Typically in the cloud, we're only using one network interface, and that would be fine. So you choose the network, click Next. Here we want to choose the target. SIOS 2 is already pre-selected for us. The volume is pre-selected. The IP all looks good, so we'll click Next. And then finally, we have some options. Synchronous replication guarantees the data is always 100% in sync. It's what you want to use for local targets. If you're replicating across regions or from on-prem into the cloud, you might choose asynchronous. You also might enable some compression. This is inline compression to save on your bandwidth. As Edwin mentioned, for egress data, you might be paying for that traffic. So if you're replicating between regions, this could save you some money as well. But for local targets, Synchronous is the way to go, and we'll click Done. This is going to initiate the replication of the R drive from SIOS 1 to SIOS 2, and in a moment we'll have a pop-up that asks us if we want to register this in the cluster. I'll say yes, go ahead, put that in the cluster. And now if I jump back to Failover Cluster Manager, if I look in my storage, you see I have a DataKeeper volume R. It's in available storage. If you've ever built a cluster, you know available storage is kind of the holding space for all your cluster storage that's not assigned to a cluster role yet. So at this point, I could add that storage to my existing SQL instance, or I could, install another instance of SQL Server, and the SQL installation will recognize the DataKeeper volume R as an available storage type. So the behavior is exactly as you would expect with a shared disk resource. That's it. That's a very quick, high-level overview. Of course, if you have want to see more about this, you can definitely. I think Greg is going to put up a poll to see if anyone's interested in being contacted by us, and we can schedule your own private webinar to dive in a little bit deeper, spend a little bit more time with you. But we do have about 5 minutes here to open it up for Q&A for Edwin. If you have specific questions about DataKeeper, I can field those. So why don't we go ahead and get to the questions now. So Greg, if you want to kick us off here.
Yep.
If you haven't submitted questions,
okay,
you can do that now as well.
Yep. So as Dave said, if you have other questions, just feel free to type them in the question area, and we'll just take them one by one. So one question somebody asked Dave was, managing the cluster, is it completely identical to managing on-premises cluster, except for the SIOS piece for the storage?
Yeah, really the GUI, the DataKeeper GUI is primarily used just for the configuration. Of course, you could do PowerShell command line as well. But once that's done, you manage it just like a regular failover cluster. So it behaves in any failure scenario exactly the way as an on-premise cluster would behave. So it's no different, which is great for people moving to the cloud. We do a lot of lift and shift where people are like, okay, I don't want to have to re-architect things. As Edwin mentioned, there's other options, platform as a service, but that requires some learning, some tweaking, some testing. People making a major shift like that maybe they want to dip their toes in the water before they jump all the way in. So they just kind of want to do a lift and shift, and this is perfect. So they can manage their clusters just like they do today on-prem.
All right. The next question somebody has is about the data replication. They're just wondering, so is there an extra cost that the cloud providers charge for the replication of the data?
Well, I guess that depends on what you're talking about. Like the geo-redundant option in Azure versus DataKeeper. Of course, DataKeeper is a software you can purchase, which obviously will cost you money. But the other option is, yes, I believe, and Edwin, maybe you can comment on this, that there are additional charges for premium storage, or whether you want to do zone redundant, geo redundant, and so forth.
There is, in fact, if you're replicating within the same data center, same Azure region, you're good, because again, like I mentioned earlier, it's the data going out of Azure. Now, they may be in the same Azure cloud, but you're still moving data from one data center to another data center. Of course, that's more for disaster recovery. But anytime you're taking data out of a region, and that includes replicating the storage level using DataKeeper from one region to another, you have to pay for it.
All right, great. All right, the next question somebody has related to the size of the database and the amount of transactions. So are there any limitations to using like DataKeeper to do clustering?
Yeah, no, we're not concerned about the size. Block level is just ones and zeros. So we have multiple terabytes, people are replicating without an issue. It really comes down to your rate of change. So every write has to be sent across the wire. So, and this is very particular in Azure, you have to be careful. Your instance size not only impacts like how many CPUs and how much RAM you have, but they also have limiters on the amount of bandwidth you get. So you definitely want to make sure that you have enough bandwidth to support your rate of change, which is very simply, if you measure your disk write bytes per second, and without compression, that will translate 1-to-1 for your network bytes sent per second. So you definitely don't want to exceed the available bandwidth. And keep in mind, you're sharing that bandwidth with clients connecting to your database as well. So you want to keep an eye on the network utilization.
And the one thing that I really like about moving to the cloud is now even developers have to really think about the cost associated with what they're doing. And the analogy that I used for this example is, you build a table, for instance, with every single column using nvarchar max. When you're on premises, you defragment an index, it's generating a lot of transaction log records when you defragment an index. And you don't really pay attention to that because everything sits in the same data center. You're moving data across machines in the same data center. But on the cloud, when you start looking at generating too much transaction log records because you're defragmenting indexes and you're moving that and copying and replicating that over to a different Azure region for DR purposes, you're gonna have to start paying for that. So now you have to think about how you optimize, you properly design your applications to minimize the amount of data generated based on the width of the columns, the size of the row, and stuff like that.
Okay, we're actually a little over in time, so I'm gonna just take one more question. I'm gonna wrap things up. So the next question somebody had: is there an easy way to test out setting up a cluster in the cloud, and how long would it take to actually set that up?
Yeah, so there's certainly in Azure, you go out to GitHub, and there's all sorts of automated deployment templates, including one for SIOS DataKeeper. So essentially, it's push button, go have some lunch, come back, and you have a 2-node configuration. Same with AWS. AWS, we have a quick start in AWS. Same concept, push the button, go have some lunch, and go kick the tires. And that holds true for pretty much anything that Edwin mentioned today. So you're always on availability groups, your S2Ds, all that stuff. Usually there's some sort of either GitHub deployment template or quick start in AWS.
And there are those templates as well on Azure. When you go through the portal, these are templates that are already available for you. You can just pick and choose which one you want to deploy.
All right, great. All right, we're going to wrap things up. So I want to thank Edwin and also thank Dave for sharing the information today, and also thank SIOS for sponsoring today's event. The webcast is recorded, and you'll receive a follow-up email with links to view the archive. We'll also get a copy of the slides from Edwin that we'll post with the archived recording of the webcast. Also, please visit MSSQLTips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MSSQLTips. Thank you for attending, and have a great day.